and you look at the climate change, try to understand why this Arctic ice is melting so fast. And this is what we did for 10 years ago. And the boat actually drifted 4 times faster than what was expected to do. So it was a change at this time to understanding of the climate change in the Arctic. And then we reflect on that and we say, what would be the impact on the ocean? And the ocean is not only water. You know, the ocean is very important for you on a daily basis. You breathe because of the ocean. The heat of the planet we emitted over the last 200 years has been 95% have been taken into the ocean. It stores carbon dioxide every day, 25%, 30% every day. So it's a huge importance, and this is mainly done by plankton ecosystem, microscopic species. You cannot see them with your eyes, so it is less than a millimeter. And these beautiful shapes, viruses, bacteria, and we did study that for 4 years across the world to understand how this machine is working. How is it producing oxygen as we breathe every day? What will be the fate of this in the future? What can we understand in the future? What can we take also from the ocean for progress? This is still ongoing now in the labs. This was done from 2009 to 2013. It took 4 years to sample the ocean, to fish the plankton across the ocean, to understand it, how it works. And by doing this, we fish the plankton and we fish a lot of plastic. Almost in every space we go, in every place on the ocean we go, whether from the Arctic or from the Antarctic, you take some plankton and you also take some small fragments of plastic, as you can see here. This is very small. This is 2 millimeters, 3 millimeters. The huge impact of plastic today is not big plastics, it's the microscopic plastic you can see in the ocean. And nearly for every shape of plankton in the ocean, every size, from small algae to big animals, you have the same size of plastic interacting with it. So there's a lot of connection between the plastic and the marine life. And the question today is this plastic going into the fishes? Yes, they eat it. Is it going into the flesh that we eat? We don't know. There's not much data on it today, but this is a big question for the future, especially in the countries where you eat a lot of fish. And this is reversible. This is the problem of the challenge of the 21st century. This is reversible if we stop throwing plastic into the rivers, into the ocean. In 50 years' time from now, this plastic will disappear from the water. It will sink, it will be on the shores, and this is reversible, as other issues have been reversed already in the past. And now we are doing a long expedition, a 2 years expedition on the Pacific, on the reefs, and we try to, again, compare these organisms, these reefs across the Pacific. We try to understand globally how it works, why it's dying sometimes, what will we doing in the future, how can we protect it better. To do that is like any disease you have when you are sick. Medicine people, they are trying to understand how it works, the cancer, for instance, the research on it, to try to find the ways to tackle it. And this is the kind of thing we do on the coral reefs as well today, is to try to find ways to change that and to tackle these global warming effects on the reef. They are kind of dying more and more.